So, uh, today we are going to integrate this expression cot x into square root of 2 plus square root 4 plus sin x dx. And when we see this expression, we see that the problem here is this whole weird thing square root of 2 plus something. This is the problem. So, we need to use substitution to replace this thing. So I'm calling it t. T is equal to square root of 2 plus square root of 4 plus sin x. And obviously, we need to replace dx as well. We need to transform that dx in the form of dt. So we need to take the derivative of this t. So when we take the derivative of this t is equal to square root 2 plus something with respect to x on both sides, it becomes dt over dx equal to, now we have an expression which involves a square root and we are taking the derivative of that expression. Whenever we have an expression which involves square root, the derivative of that thing is always 1 over 2 times square root of that expression. And why am I saying that? Because if you see here, we have I have taken the derivative of square root of x. And when we take the derivative of square root of x, square root of x is just x raised to power 1 by 2. So we need to apply the power rule. And when we apply the power rule, we know how to apply the power rule. The power comes in front. So 1 by 2 will come in front. And we have to subtract 1 from the original power. So 1 by 2 minus 1. And then we need to take the derivative of that expression which was being raised to some power. So here we have x which was being raised to 1 by 2 power, and we are taking its derivative with respect to x. So we need to take the derivative of this x with respect to x, which is just 1. So we get this answer 1 by 2 x raised to power minus 1 by 2. And if we want to make this negative power positive, we need to take this to the denominator. So 1 by 2 times x raised to power 1 by 2, and x raised to power 1 by 2 is just square root of x. So the derivative of square root of x with respect to x is simply 1 over 2 times square root of x. So the point of this discussion was that whenever we have an expression which involves square root, its derivative is just 1 over 2 times square root of that expression which is written inside the square root. So here we have basically square root of 2 plus square root of 4 plus sine x. So this 2 plus square root of 4 plus sine x, this is written inside that big square root. So its derivative will be 1 over 2 times square root of this entire thing, 2 plus square root of 4 plus sine x. And then we take the derivative of this inside expression. So when we take the derivative of this inside expression with respect to x, what is written? 2 plus square root of 4 plus sine x. So the derivative of 2, it is a constant. It doesn't have any, it is not changing. It's a straight line, horizontal line. So derivative means slope. So horizontal line doesn't have any slope. So that means the derivative of 2 will be 0. Plus, again we have another square root, and we know the derivative of square root is simply 1 over 2 times square root of that expression plus into the derivative of the inside expression. So 1 over 2 times square root of 4 4 plus sine x. This is the derivative of square root of 4 plus sine x, 1 over 2 times square root of 4 plus sine x. Also, we need to take the derivative of the inside expression, which is 4 plus sine x. So 4 has a derivative 0 and sine x has the derivative cos x. So again, we had a square root expression and we needed to take its derivative. So the derivative of a square root expression under square root is just 1 over 2 times square root of that thing. So we get 1 over 2 times square root of this entire thing. And next we needed to take the derivative of the inside thing, which is 2 plus square root of 4 plus sine x. The derivative of 2 is 0. And the derivative of this square root of 4 plus sine x is again 1 over 2 times square root of this thing. And now we need to take the derivative of this inside 4 plus sine x expression, which is simply cos x. So now we need to simplify for the value of dx, because we need the value of dx in order to solve this integral. So we have dt over dx is equal to this thing. So we need dx. So dx is being divided on this side. It will be multiplied on the other side. And we want the value of dx. So this entire thing, which is written with dx, is being multiplied with dx. It will be divided on the other side. So dt divided by this entire thing is equal to dx. And we want the value of dx, so we need to change this division sign into multiplication. And when we do that, we basically invert the second fraction. So in the numerator we had cos x, and in the denominator we have this 2 times square root of that entire thing into 2 times square root of 4 plus sine x. So these two square root expressions go to the numerator and cos x goes to the denominator. So we now have the value for dx. We now have the value for this weird expression, square root of this entire thing. And now we will use those values and replace these values by those values. So it will be integral of cot x into this expression, we called it t. So cot x into t into dx. So dx has value dt into 2. So 2 into this thing is called t. So 2t into 2 into square root of 4 plus sine x. So we need to find the value of this 4 plus sine x square root. And for that we will use our original equation, which was t is equal to square root of 2 plus square root of 4 plus sine x. So we are interested in square root of 4 plus sine x. So we will square both sides. So when we square both sides, we get t square is equal to 2 plus square root of 4 plus sine x. So the bigger square root cancels out because it was on the whole expression. It gets cancelled out with the outside square. So we get square root of 4 plus sine x is equal to t square minus 2. So we will replace square root of 4 plus sine x in our calculation here with t square minus 2. This thing was t. Cot x was present in the question into that thing which we call t into dx. So dx has this value dt, this is dt, into 2, this is 2, this is t, this is t, into 2, this is 2, and this was t square minus 2 divided by cos x. So cot x is just simply the reciprocal of tan. So tan is sine over cos, so cot x will be cos over sine. Cos over sine into t into 4t into t square minus 2 into dt. So what advantage do we get writing this cot x in this form? We get this advantage that this cos x and this cos x cancel out. And we are left with 4t square, 4t into t. They multiply to give us 4t square into this t square minus 2 divided by sine x, this sine x. So 4t square into t square minus 2 divided by sine x, and we are integrating this with respect to t. Now the numerator is in the form of t, But this sine x is still in terms of x. We wanted to transform this whole integral in the form of uh, in terms of t. So we need to replace this sine x with its value in terms of t, and for that we will again use this thing. Square root of 4 plus sine x is equal to t square minus 2, and we are interested in the value of sine x, so we need to remove this square root. So for that we need to take the square on both sides. When we take the square on both sides, we get square and square root cancel out, and on the right hand side we get t square minus 2 whole squared. So we get 4 plus sine x is equal to t square minus 2 whole squared. We are interested in sine x, so 4 is being added on the left side, it will be subtracted from the right side. So sine x is equal to t square minus 2 whole squared minus 4. So we have found the value of sine x in terms of t. We will just put the value of sine x here. So it is just simply t square minus 2 whole squared minus 4. And from here we can see that this t square minus 2 whole squared minus 4, we can write this 4 in the form of 2 squared. I'm writing this because we want to transform this in the form of a square minus b square, so we can factorize it. So we get 4t square into t square minus 2, and when we factorize it, basically a square minus b square has in factor form is basically a plus b into a minus b. So we had, when we factorize it, it becomes t square minus 2 t square minus 2 plus 2. So minus 2 plus 2 cancel out, and we are left with 4t square into t square minus 2 over t square minus 2 becomes minus 4 into t square. So t square and t square cancel out, and we are left with 4 into t square minus 2 over t square minus 4. This 4 is a constant. It's a coefficient, so it can be moved outside the integral. So we move it outside the integral. So it becomes 4 times the integral of t square minus 2 over t square minus 4 dt. Now we see that we have a fraction, and it's basically an improper fraction. We call it improper fraction because the degree of the numerator is equal to the degree of the denominator. Both have the degree equal to 2. And when that's the case, whenever the numerator has the degree equal or greater than the denominator, we transform that improper fraction or change that improper fraction into proper fraction by long division. So I'm using long division here. So t square minus 2 is being divided by t square minus 4, and t square minus 4, when we multiply it by 1, we get t square minus 4 as it is. And like this simple division involving numbers, in long division we also in long division of expressions we also subtract. So when we subtract t square minus 4 from t square minus 2, the signs change. Plus becomes minus and minus becomes plus. T square and t square both have opposite signs now. The t square written above has the sign plus, and the one written below that t square has sign negative sign. So both cancel out. We are left with minus 2 plus 4, which is simply 2. So now we can use the Chinese remainder theorem, and which just simply states that whenever we have a fraction and we use division to write it, we simply write it in the form of our quotient plus our remainder divided by our divisor. So quotient was just 1 plus remainder was 2 over the divisor, which was t square minus 4. So now we can see that what advantage did we get from this long division thing, that we were able to write a fraction in the form of 2 terms, and whenever we have 2 terms we can apply linearity property of the integration, and we can simply integrate both of those terms separately. So 1 plus 2 over t square minus 4, these are two terms, and we will integrate these two terms separately. So 4 times the integral of 1 with respect to t plus the integral of 2 over t square minus 4 with respect to t. The integral of 1 with respect to t is simply t, because we are integrating with respect to t, and integration is basically finding the antiderivative. We you know are thinking that which function has the derivative equal to 1. So we are integrating with respect to t. So t is the function which has derivative equal to 1. So that's why the derivative of 1 with respect to t is simply t. But we don't know the solution of this 2 over t square minus 4 yet. So we need to integrate this expression in order to find our final answer. So for that, we see that in the denominator we have t square minus 4, which can be written in the form of t square minus 2 squared, which is a square minus b square, and a square minus b square can be factorized in the form of a minus b into a plus b. So we get 2 over t square minus 4, and we are integrating this with respect to t. From that we get 2 over t minus 2 into t plus 2. So that expression 2 over t minus 2 into t plus 2, this can be solved through, we can't integrate it directly, obviously. We need to use partial fraction resolution in order to write this expression in the form of sum or difference of two fractions. So I was saying that we needed to we need to transform this 2 over t minus 2 into t plus 2 in the form of a sum or a difference of two fractions. For that we use partial fraction resolution, and this expression can be written in the form of two fractions, and these two factors will be the denominators of one of those fractions. So t minus 2 will be the denominator of first fraction, and t plus 2 will be the denominator of the other fraction. And we need to put a numerator such that the fraction remains proper. So t minus 2, so the degree of numerator can't be equal or greater than the denominator has degree equal to 1, so it must be equal to, the degree of the numerator must be equal to 0. So that means that we have a constant, because when variable has a degree equal to 0, it becomes a constant, anything raised to power 0. So t raised to power 0, we have the variable here t, so it's 0 degree is t raised to power 0, which is a constant. So we are calling it the constant, we're calling the constant of first fraction as a and the second fraction as b. So we need to find the values of these a and b. For that we multiply both sides by t minus 2 into t plus 2. We get 2 is equal to a times t plus 2 plus b times t minus 2. And when we multiply a with this and b with t minus 2, we get a into t plus 2 is at plus 2a, plus b into t minus 2 is bt minus 2b. And we are interested in the values of a and b, so we need to make two equations, because we have two variables which we need to find. So for that I've taken t common from at and bt. We get a plus b, plus the constants are 2a minus 2b. So we can compare the coefficients of the variables to get the equations. So when we compare the coefficients of t, we get a plus b equal to 0, because on the left side we don't have any value, we don't have any term involving t, so that means its coefficient is 0. And when we compare the constants, we get 2a minus 2b equal to 2. So we get these two equations, and we will solve these two equations to get the values of a and b. So I'll solve these two equations simultaneously by equating their coefficients, and for that I am multiplying the first equation with 2. I get 2a plus 2b equal to 0. We multiply the left side with 2, we get 2a plus 2b, and when we multiply the right side by 2, we get just 0. So we have this 2a plus 2b equal to 0 now, and the second equation is 2a minus 2b equal to 2. So we can easily eliminate b from here by simply adding both equations, because b's have the terms involving b have opposite signs, plus 2b and minus 2b. So when we add these two equations, we get 2a plus 2a, which is 4a, plus 2b minus 2b cancel out, and on the right hand side we are left with 0 plus 2 simply, which is 2. So 4a is equal to 2. We are interested in the value of a. We will divide this 4 on the other side. We get a is equal to 1 over 2. And when we put this value of a in either of those two equations, I'm putting this value of a in first equation, we'll get the value of b. So a plus b was equal to 0, and a is just simply 1 over 2. 1 over 2 plus b equal to 0. So 1 over 2 is being added on the left side. It will be subtracted on the right hand side. So we'll get b equal to minus 1 over 2. So we have both values with the value of a and b. We just now need to put those values in that partial fraction resolution, and we can integrate that thing easily. So integration of 2 over t square minus 4 was equal to 2 over t minus 2 into t plus 2, and this 2 over t minus 2 into t plus 2 was equal to a over t plus t minus 2 plus b over t minus t plus 2. So a was 1 over 2, so 1 over 2 times t minus 2 minus 1 over 2 times t plus 2. So we've just simply put the values of a and b in that partial fraction resolution. So we have this situation now, which is easier to tackle, or which can be tackled, because we have two terms and we can use the linearity property of integration to integrate those terms separately. So it will be equal to integration of 1 over 2 times t minus 2 with respect to t minus the integration of 1 over 2 times t plus 2 with respect to t. So 1 over 2 is just coefficient, we can take it outside. So 1 over 2 times integral of 1 over t minus 2 with respect to t minus 1 over 2 times the integral of 1 over t plus 2 with respect to t. And this 1 over t minus 2, we can see that the derivative of the denominator is written in the numerator. T minus 2, when we take its derivative is simply 1, because derivative of t is 1 and minus 2 is 0. So this expression has the derivative equal to 1, which is written in the numerator, and whenever the derivative of the denominator is written in the numerator, we basically, its antiderivative is natural log of absolute of that denominator. So 1 over 2 times natural log of t minus 2 absolute minus 1 over 2 against again the same situation, but this time the denominator is t plus 2, which makes absolutely no difference. So minus 1 over 2 natural log of absolute of t plus 2. So we have found this, the integral of this 2 over t square minus 4 term. So we had two terms, 4 times the integral of two terms in our answer. So our final answer will be 4 times t, because we were we had the antiderivative of 1 with respect to t, so that is simply t. So 4 times t plus this, the integral of this 1 over the integral of 1 plus this thing. So 1 over 2, I've taken 1 over 2 common from these two terms. So 1 over 2 times natural log of t minus 2 minus natural log of t plus 2 absolute. So as you can see that we have natural log of two things and they are being separated. So whenever we have this kind of situation, we can write this thing in the form of division. So this will become 4t. 4 is being multiplied by these terms. So 4 times t is 4t plus 4 times 1 over 2, which is simply 2. So natural log of these two things, t minus 2 absolute divided by t plus 2 absolute. And finally, we know that the original question was in terms of x, not t. So we need to replace the value of t here. So 4 times square root of t was 2 plus square root of 4 plus sine x plus 2 natural log of this entire thing, and will replace the value, will write the value of t. So absolute of square root of 2 plus square root of 4 plus sine x minus 2 absolute divided by absolute of square root of 2 plus square root of 4 plus sine x plus 2, and plus the constant of integration. And from the properties of absolute, we know that the quotient of two absolutes can be written in the form of the absolute of the quotient. So this thing remains the same, plus 2 natural log of the absolute of this entire thing, the quotient of these two things, plus the constant of integration. This is the final answer for this question.